So far, we have learned about variables and we have learned about loops. I will now show you how to use variables in conjunction with loops. To do so, let's look at the following scenario. Suppose I'm taking a hike in the forest and I'm hiking for, say, 9 miles. Every mile, I pick up 3 hazelnuts. And I'd like to print out how many nuts I have in total after each mile. So to do so, I need to store 2 quantities, how many nuts I have at any point in time and how far I have traveled. So let's do that. Let's declare 2 integer type variables, one of them being the number of hazelnuts. And whenever we declare a variable, remember we should also initialize it. And initially I have none, I haven't collected any hazelnuts yet. And then another variable that stores how far I have hiked so far, so distance traveled. And again, at the beginning of my hike, I haven't traveled any kind of distance yet. So now every mile, at mile 0, at mile 1, at mile 2, at mile 3, and so forth, I would like to print out how many hazelnuts I have collected so far. That sounds like a loop to me. So let's paste in our typical loop statement. For I equals 0, I less than 9. I'm going to repeat this loop 9 times. That's why I put in 9 here, I plus plus. And we're going to need a closing brace at the end of this loop. And then we have to put something in there. Now remember, whenever we have this loop, the I that you see in here is actually a variable. We haven't really spoken of it as a variable, but I need to declare this variable just like I need to declare any other old variable. So we'll understand that more later. For now, I'll just put it up there. So here's my loop. 9 times I want to repeat something. What is it that I want to repeat? Well, I'd like to print out how many hazelnuts I have. So I need a printf statement that says that at so and so many miles, and this %d will be replaced by 0, 1, 2, 3, and so forth. So at %d miles, I have, and then whatever many hazelnuts I have. And let's start a new line after each statement so we can read it more easily. So now I need to put in what these %ds should be replaced with. Well, it's the distance traveled for the number of miles. So distance traveled right here. And for the number of hazelnuts, I called that variable number of hazelnuts. And that's it. So that's a printf statement that prints out how many hazelnuts I have at a certain distance. But now I need to update these variables. Initially, I initialized them as 0, but they don't stay 0. After the first mile, I have actually collected some hazelnuts. So I need to change what's stored in number of hazelnuts as well as change my distance traveled. So after each printf statement, I need to actually increase distance traveled by 1 so that I'm getting ready for the next printf statement. So how do I do that? I write distance traveled equals, and now I need to state an update statement. Distance traveled plus 1. Now that looks really weird, right? That doesn't seem mathematically true. You can't say distance traveled equals distance traveled plus 1. But remember, this equal sign is not a mathematical equality, it's an assignment statement. It means that we take the right-hand side, evaluate what's on the right, and assign the result of the evaluation to the variable on the left. So the first time we're in this loop, distance traveled is still 0 from my initialization. So this variable here has the value 0. We're taking that 0 by adding 1 to it. So the right-hand side evaluates to 1. And that value is then assigned to distance traveled. In other words, distance traveled is updated with the value 1 if it previously was 0. If it previously was 1, then it would be updated with the value 2, and so forth. So this statement updates distance traveled by increasing it by 1. Similarly, my number of hazelnuts needs to be updated. And how does it need to be updated? Well, I collect 3 hazelnuts for every mile that I travel. So I need to add 3 to the current number of hazelnuts in order to get the new number of hazelnuts. Number of hazelnuts plus 3. And now I have updated both of my variables and my loop is complete. I'm printing how many hazelnuts I have at a certain mile, and then I'm updating my distance traveled and my number of hazelnuts to get ready for the next printf statement. Let's compile and run this code. And it says at 0 miles, I have 0 hazelnuts and a lot of other stuff. So let's go through this slowly. Remember, initially, the number of hazelnuts is 0 and the distance traveled is 0. That's how I enter my loop. So the first time I get to this printf statement, distance traveled is 0 and number of hazelnuts is 0. And that's why it prints out at 0 miles, I have 0 hazelnuts, the first statement you see in the terminal window. Next, I update distance traveled by adding 1 to the old value of distance traveled. So 0 plus 1 is 1. Distance traveled now has the value 1. And then number of hazelnuts is updated by adding 3 to the old value 0. So 0 plus 3 is 3. So distance traveled and number of hazelnuts now have the value 1 and 3 respectively. And a loop means that these 3 statements are being repeated over and over and over again. So next I get back to this printf statement, but this time the new values are going to be printed. So it's going to print out at 1 mile, I have 3 hazelnuts. And that's what you see in the second line that got printed out. Then distance traveled is updated again and now becomes 2. Number of hazelnuts is updated to have the value 6. And we get back to the next iteration of the loop with the printf statement. It now prints at 2 miles, I have 6 hazelnuts. And it keeps going and going and going like that until I get to at 8 miles, I have 24 hazelnuts. Why did it stop at 8? I wanted this loop repeated 9 times. Well, it actually did repeat 9 times because we started at 0. So 0 gets printed out during the first iteration of the loop. 1 gets printed out during the second iteration, and so forth. 8 gets printed out during the 9th iteration of the loop. So the loop was indeed executed 9 times. So this is how we can use variables inside loops.